Today we will be learning about seafloor spreading. Seafloor spreading is the formation of new areas of oceanic crust, which occurs through the upwelling of magma at mid-ocean ridges and its subsequent outward movement on either side. To fully understand the process of seafloor spreading, we must first understand the mechanism or process by which seafloor spreading occurs. Deep inside the earth, heat is transferred by convection. Convection is the movement caused within a fluid by the tendency of hotter and therefore less dense material to rise and colder, denser material to sink under the influence of gravity, which consequently results in the transfer of heat. As a result of convection, currents within the mantle form called convection currents. Convection currents are simply a current in a fluid that results from convection. Tectonic plates, which make up the hard, rocky surfaces of the earth, are moved by the motions of convection currents. Now that we know the mechanism or the how of seafloor spreading, let's look at the details of what seafloor spreading is by modeling. Modeling is a great way to understand a process in greater depth. However, a good model needs labels to effectively communicate information. Let's label our model together. The green represents continental crusts. These long, round pieces represent oceanic crusts, which is just another name for the floor of the ocean. Our blue is our ocean. Our upper mantle is orange. Our red represents magma. Magma is going to be hotter and therefore less dense than the upper mantle, which is going to be cooler and more dense, which will cause a convection current as the magma rises and the upper mantle sinks. So we can label our convection currents. Where the magma meets the oceanic crust in the ocean is our mid-ocean ridge. And remember, the place where one crust goes below another crust is called our subduction zone, which we can see right here as the oceanic crust is pushed underneath our continental crusts. So we have two subduction zones. Now that we have our model labeled, let's see how convection causes seafloor spreading. We know convection, or the rise of hotter and less dense material and the sinking of cooler, denser materials, creates convection currents. These currents can actually move oceanic crusts away from each other at the mid-ocean ridges. So let's place arrows showing the movement of these oceanic crusts away from each other at the mid-ocean ridge. Where the oceanic crusts are thin, magma can bubble up and actually fill in that rift or gap. So we're going to put an arrow showing our magma bubbling up. As the magma bubbles up and meets the cooler ocean water, it hardens, forming new oceanic crust and causing the seafloor to spread. Where these oceanic plates collide with continental crusts, where we call the subduction zone, and the oceanic crust bends underneath the continental crust, it actually, under heat and pressure, remelts and joins the upper mantle and continues the convection current.